Jai Hind everyone, myself Puneet Saini, Scientific Officer, AKGC Skills Foundation. Today I will be giving presentation on the topic design for manufacturing. Jai Hind everyone, myself Puneet Saini, Scientific Officer, AKGC Skills Foundation. Today I will be giving presentation on the topic design for manufacturing. So let us start our presentation. So these are the contents that I will be following during this presentation. I'll start by introducing what do we mean by design for manufacturing, what are the essential principles that govern it. Then we'll start with the case studies. We'll be studying two case studies. One case study of Apple iPhone, comparing it with Samsung Galaxy S series, and next case study will be printer, one of Epson and another of IBM printer. Then we'll study industrial revolution, in which we will be discussing about how design for manufacturing is linked with industrial revolution. Then we will study the key technique of industrial revolution 4.0, which is additive manufacturing. Then we'll be studying about the center of excellence of AKGC, that is PLM Center of Excellence, and Fab Lab. So let us now start with the introduction section. Now I'll start my presentation with asking you a question, which is, do you know how to make these parts? Like these are parts that you can see in your screen. These are intertwined with each other. Their shape may be complex. And another part that I can say is of this. Hope you can see it in camera. These two complex parts. Can you think about this, how to make this part, or what kind of material, like it can be plastic or it can be polymer, composite, what kind of material will be required to make these complex parts, or which manufacturing process do we use to make this part? Like it can be manufactured by using casting or injection molding or powder metallurgy. Like this is the question, that how can we make this part, or how much does it cost to make this part, or how long does it takes to make this part. Like some manufacturing process takes few hours to few days to make this part. So this is the question that I want you all to think about. So these issues are governed by manufacturing processes, like which manufacturing process would you be using to manufacture this part, or which machine is available to you to manufacture this part, what kind of material do you require, or what is the batch size of it, etc. So these are some of the issues which are linked with manufacturing of these parts. So with these questions in your mind and factors which influence these, so maybe you will getting some type of understanding, like to make these types of parts you would be needing to know what kind of manufacturing process is required, or what kind of machines is available with you. So I generally start my presentation in the middle of it with a quote, and in screen you are seeing Mr. Tom Peters. He is a very renowned author in the field of design for manufacturing, and there is a very famous quotation which are used by many engineers, which is, almost all quality improvement comes via simplification of design, manufacturing layout, process and procedure. Meaning, if we want to improve the quality of a product, we only have to simplify its design, we have to choose the right manufacturing processes, and we have to decide the layout through which how we want to use which manufacturing process or layout, and the procedure for it. So if we can govern the design and manufacturing, which are the main aspect, then we can improve the quality of the product. This was said by Tom Peters, who is also known as the prominent figure in design for manufacturing. So if we compare traditional design with design for manufacturing, so the question must pops in your mind, like how design for manufacturing, or DFM which we call it, is different from a traditional design. So let me ask a question with you, and those who are seeing it in live session, just think about it a moment. You have a figure in front of you, and left side there is a tabletop, and right side there is also a tabletop. Can you recognize which one is the traditional design or which one is the design which is used by DFM? Just think about it. Those who are watching it afterwards, after this live session has ended, just pause this video for a moment, take your time and think about which of the following process will be traditional design and which of the following process the products is manufactured with DFM. So here you can see this is a tabletop, and this tabletop on the left side contains 7 parts. These parts are like this. This is the first part, second part, third, fourth, fifth, sixth and seventh. And to manufacture or to assemble this, you would be needing 9 assembly steps. Like this part will go inside this part. So this will be first assembly step. Essentially, if you join all this together, it will constitute of 9 assembly steps. On the right side, if you see this figure, this is the first part, that is part A, and this is the second part, that is part B. Now, if you want to assemble it, there is only one assembly step, meaning this area will go inside this. So we can say there are only one assembly step in this process. So I think it is quite evident that on the left side of the figure, it is conventional design, and on the right side of the figure, it is design for manufacturing. So what we can get from this is, when we are designing a product with the principle of design for manufacturing, that is DFM, we are reducing the assembly steps. We are designing the product, or we are choosing the manufacturing process in such a way that the assembly steps are reduced. So that is how the principle behind design for manufacturing is. Now, let us define what is design for manufacturing. So design for manufacturing involves with effectively designing an object to reduce the production cost. So we are designing any product which we want to manufacture in such a way that it is reducing the production cost, and by optimizing selection of material and manufacturing processes. Like there are advanced digital manufacturing tools available with us, through which before feeding the product for manufacturing, we can simulate it and see whether the manufacturing process which we are choosing will be perfect for the product or not. So these digital manufacturing tools helps us to identify whether the manufacturing process we have chosen for the product is right or not. So this is also the part of design for manufacturing. So we can understand what the definition of design for manufacturing is, that our main objective is to reduce the production cost by designing an object and choosing the manufacturing process in a good way. Now, let us discuss the focus area or the DFM principles. So DFM focuses on 5 essential aspects, which is manufacturing process, product design, product material, service environment, testing and compliance. Manufacturing process, again, as we know, a product, it can be manufactured using various processes. Like a product can be manufactured using casting or powder metallurgy or a forming process, but which product requires a specific manufacturing process, we need to know. So, and product design, we want to design our product in such a way that if later on in the design stage, some customer or the customer which we are giving product to wants to modify the design by getting some feedback, so its modification is also easy. So that governs with product design. And product materials means we want to choose a material which is required by the industry, which is cheaper to us. And next is service environment. Service environment deal with the product. Suppose a product is being used in a dusty environment, so what kind of material should we choose so that the product can be used in that environment. Testing and compliance means we are testing the product with various industrial tests available to us. So let us start with discussing every principle of DFM. So first, let us start with manufacturing process. So it is very imperative that we use the right manufacturing process. So right manufacturing process deals with, we want to access the cost, we want to access the product material which we require to manufacture product, what kind of surface finish do we require, post processing needs, like what kind of machining do we require, and tolerance we want to set for the right manufacturing process of a product. Like if we compare, suppose if we know a product can be manufactured with injection molding or additive manufacturing, so which process to choose? Injection molding is a process in which we feed the molten metal into a mold cavity and give it some time to cool down. When the material is cooled down, we get our desired product. But injection molding process is not useful for small batches. We require large amount of batches for this manufacturing, for this injection molding manufacturing process. So the alternate could be the additive manufacturing. We can use the 3D printing technology for it. Because if the batch size is small and we readily want the product to use it for manufacturing purpose, so we should go for additive manufacturing, and plus it is much cheaper than the injection molding. So choosing the right manufacturing process for our product is also very important. Last point for manufacturing process is tolerances. We don't want the tolerances for the product to be very tight. If the tolerance is tight, it will essentially increase the production cost. So this is what manufacturing process using DFM was all about. It's all about choosing the right manufacturing process. Next is product design. Now product design is a very important phase in design for manufacturing, and it deals with 6 essential steps. First, we want to understand the problem, which is empathize and understand. So to understand the problem, let me give you an example of a case study. Currently I am working in the area of robotics, that is service robotics. So if I take an example of an agriculture robot, if you want to understand a problem, you just have to go outside and meet people. They will tell you about your problems. So let me give you an example of agriculture robotics. So we know India is an agriculture prominent country. During lockdown, only agriculture was there who has the GDP of in positive percentage. So till now many people depends on agriculture, but the traditional practices that farmers use are obsolete. They don't use new technologies for their farming practices. So if you when I went to the farmers to understand their problem, I'm giving you my example of this product design. So they told me that whenever they are sowing the seeds, so besides them weeds also grow. So weeds compete with the nutrients and sunlight, essentially hampering the growth of the plant. So farmers' profit depends upon how much quantity of product they are giving to the industry, like how much quantity of product in tons or in quintals they are selling it to the market. So if because of weeds their production decreases drastically, maybe about 10 to 20%. That is a lot if we are comparing in the amount of tons or quintals. So the weeds was the main problem which was hampering the production. So this is how you understand the problem. You try to understand the user needs. Then after understanding the problem, you define it. You take a piece of paper and you write down all your problems which you have understanding by contacting with the people. You discuss the scope of work, you discuss the success criteria, whether this product will be successful or not, and you then it includes the planning stages. Like you try to define the strategy which you want to obtain. So second stage essentially consists of defining. Third is ideate. Ideate means you start working on your design. You try to formulate simple steps, like how if you have defined the problem, how you are going to solve it. Like you try to determine the potential solutions for it, you try to develop a structure for it. So this is what ideate is all about. The next step is design and prototype. The next step comes, which is design and prototype. So design and prototype means you design using a CAD software of your product and you try to fabricate it with various technologies that is available to you. Now after developing a prototype, you go for testing and implementation, which is a very important part. You try to figure it out whether the product which you have developed or fabricated, it is useful to the end customers or not. And if it is not useful, you go for the review pattern, meaning the feedback for which you are trying to develop your product is very important. Like sometimes the product which you're developing for, they tell you that they don't like the design or aesthetics for it, or it is not working properly. So feedback mechanism is very, very important during this product design phase. You implement it, then you test and learn. So this is, as you can see, this is a continuously evolving process. Sometimes the user gives you different types of feedback and you develop it according to it. So this product design consists of total of 6 steps with review in between, and which is very important. So design and manufacturing, they are important parts of DFM. Now let us move further with the next principle, which is product material. Now selection of material is again very important from if we are talking about the DFM. Now aspects, materials, selection of materials means we want to check whether the strength of the material is good or not. Strength meaning the load bearing capacity of the material. Now if I talk about load bearing capacity, means suppose let me give you an example of automobile. In automobile there are various moving parts. So various moving parts, there may be cyclic loading. Cyclic loading leads to fatigue loading, in which stresses reverses their direction and load is not constant at every time. So for that we need a very strong material who is ductile and who can bear this cyclic load. So we want that kind of material for it. So we have to check which type of material is important, like whether it is thermal resistant, whether it is electrical resistant. Thermal resistance meaning it is able to bear that amount of heat or not, whether the surface finish which is required for us is good or not, whether it is flammability, like for example if we are designing a part for a rocket. Now rocket have to go to outer space, so there may be lot amount of heat. So whether that material is flammable or not, or that material is machinability of the material is good or not, whether we can machine it with easily or not. So this is what product material selection means. And another aspect of this also is what kind of grade which we are using for a product manufacturing is also important. Like if I say example of aluminum plate and aluminum bar stroke. So aluminum bar stroke cost half the price of aluminum plate. So rather than choosing the plate, you can also opt for bar stock. So this is also very important, like which you choose, which kind of grade is required for you. Next is service environment. Now service environment also plays a very important role when we are discussing the design for manufacturing. Like effective DFM process is to evaluate service environment, create a functional product at a low production cost. Now if our product is working in a dusty area, that product cannot work underwater. Now environmental factors also, like rain, wind, dust, soil and moisture, also plays a very important role in which type of product you are using for manufacturing. These all things must be considered during the DFM process. Now let us take an example of a grade of aluminium, that is 5083. It is a marine grade aluminium and which is very much useful for marine application. Now if you use we use this 5083 marine grade aluminium for marine application because it is highly corrosive resistance. Now if you use this grade of aluminium outside of water, then there is no need because inside of water the chances of corrosion is very high, and if you use this material outside in open air, the chances of corrosion is very less. So we don't want to use this type of material for that purpose. So selection of material according to service environment is also very important, and this is also important part of DFM principles. Next and last part is quality testing. Like you have manufactured a product, now you want to send it for, you want to launch it to the customers. So quality testing is also very important part of it. Like there are various industry standards which are available to ensure the quality of product. Now it governs with, there are various, like for example, there are stress, load and testing. There are real world test simulations which you can use to see whether your product will be useful or whether that product will be able to bear that environment when it is out in the open for people to use. There are questionnaire process, there are end user collaboration, and there is automatic testing, automation also, and employee testing techniques. So these are also very important to check the quality of a product which you are manufacturing. Let me give you an example of quality testing. Recently, you have seen that many electric scooters are catching fire because of the battery that is used, that is not suitable for environment according to India, because in some parts of India there is very high amount of moisture content or very high amount of heat, like in parts of Rajasthan, and in parts of Himalayas the temperature goes down 0 degree. So the product which you are manufacturing, it should be very important that it is passing through every kind of test. It is passing through the test of heat, or it is passing through the test of cold, or in which service environment that the product is going to work. So all these points and all these criteria, all these principles which I have talked about just now, these 5 principles are the focus area on which design for manufacturing essentially works. Now let us study the applications of it and the reasons why DFM is invaluable in the competitive markets of the present day. So if we want to build a realistic cost model in line with product objectives, so that is where we use DFM, and we want to minimize manufacturability issues so that products can be manufactured quicker and in a more economical way. Like I gave you an example of a tabletop earlier, in which in one area we were using more than 8 assembly steps. In one step we were using only 1 assembly steps. So we want to increase the manufacturability. It means how we are manufacturing a product. So we want to use the DFM principles so that the assembly steps are pretty less. Now we also want to create an effective design that leaves room for a potential design changes in the later stages without a huge cost. Now it is a very important step, as I think I have also talked about it earlier, because whenever in customer demands in the end, sometimes using the user feedback, some people say that we want this changes in the design. So the design should be in such a way that whenever you want to change the design at the end stages, it shouldn't affect the manufacturing processes. So design should be made in that way. Certain unnecessary design features that add cost and eliminate them. So this is one of the application of DFM. Drive down suppliers' bid by modifying the design using DFM principle. So these are all the applications of design for manufacturing. Now I think you are getting an idea now that how manufacturing and design and manufacturing are important for DFM. Now let us study. Now let us see the case study for it. The first case study, we want to see what kind of assembly do we need. So assembly from heaven. Assembly from heaven essentially means like the product which you are using is used for assembling. Like it can be assembled by a blind person wearing a glove box. It's stable and self-aligning. Tolerances are loose and forgiving. Few fasteners, we are able to tighten it and loosen it without wasting any time. There are very few tools and fixtures. Part presented in the right orientation. Parts are asymmetric for easy feeding, and parts are easy to grasp and insert. So if a product is like this, assembly steps are like this, then we can say the assembly is from heaven. It's very easy to assemble. Now let us talk about assembly from hell. Now I have taken here example of an iPhone 4, and its assembly steps are exactly opposite in each case from the previous slide. Here you can see assembly components of iPhone 4. These are various components which we require to assemble the iPhone 4. Here you can see there are total number of screws 52, and these are assumed value just to show that the assembly of iPhone 4 was very difficult, and the number of components are 14 and screws are 52. So essentially assembly steps will also increase. Now if we compare it with Galaxy S3, and there are total number of screws are 11 and number of components is 8. So if we compare between them two, here we can see that the assembly steps of Samsung Galaxy S3 at that time when these both these four phones were launched, it's very less. So because of the less number of screws and less number of components. So I have taken this data from a professor of Seoul National University, SNU. And so from these two comparison, we can say that the assembly components of iPhone 4 was very difficult. Now, there was also an article from Wall Street Journal, which was published on October 17, 2012, and it was about the assembly issue of iPhone 4. And it said the iPhone 4 is the most difficult device that Foxconn, now Foxconn is a company which assembled iPhone products, has ever assembled. To make it, so their objective was to make the design light. To make it light and thin, the design is very complicated, said an official at the company who declined to be named. Now, it takes time to learn how to make a new device. Practice makes perfect. Our productivity has been improving day by day. So they also admitted it that this assembly, they were facing an assembly issue and they were working on it to improve it. So this was an anonymous person who didn't want to be named told this, and it was published in a Wall Street Journal. So we can say this was a case of design for manufacturing. Like if they would have used a different manufacturing step, the assembly would have been easy. Now let us see another case study. Now this case study is of Epson printer. This printer was manufactured in the year 1987. It was a dot printer, and here you can see the total number of parts were 49. Here are the various parts of an Epson printer, and assembly work was 57 times. Like 57 times you have to assemble different types of products, and assembly time was 552 seconds, and labor cost was $3.83 at that time. So if we compare it with an IBM printer, like here's the number of parts of IBM printer and there are number of parts of Epson printer. So IBM printer was also launched in the year of 1987, and it was also a dot printer, and it was designed for assembly. It was a good design. The main assembly of IBM printer, it contained only 32 parts, comparing with the Epson of 49 parts, and assembly go was only 32 time, and assembly work in case of the Epson printer was 57 time. The total assembly time taken was 170 seconds, and for it was 552 seconds. Labor cost was $1.18, and labor cost for Epson printer was $3.83. So here you can also see, if you are decreasing the assembly time, then the labor cost also increase, because in 24 hours, if a factory is working for 24 hours, they are able to assemble more products, meaning more products are available in the market. So labor cost essentially will decrease. So here you can also see, if assembly, you are able to decrease the assembly time. If you are using the proper DFM principle, you are able to decrease that assembly time. Then the labor cost, essentially production cost, also decreases. Now, I think all of you must have gotten an idea of what design for manufacturing is all about. We were talking about how we can improve the design. Then we were talking about how, if we are choosing the right manufacturing process and we are using the right service environment, right material, and correctly implying the DFM principles, then our product will have very low production cost, and it will genuinely stay more in the market. So design and manufacturing. So let us now let us go down in history and start with how it is connected with industrial revolution, and how it has changed with time, how the industrial revolution impacted it. So same, it is written here that design and manufacturing is important for DFM. Now let us see how this has changed with time. So it started in the industrial revolution, started in the year of 1784. The mankind has discovered the power of steam, and we were using steam to manufacture different kind of products. This was now the first industrial revolution, started from around 1784 and lasted till 1870, near about 85 to 90 years. In 1870, the mankind was introduced with electricity, and when there was electricity, there was mass production, there was electrical energy, assembly line production was increasing. Then this industrial revolution lasted for 100 years. In 1969, there was automation. We were using robots and computers to manufacture products. Now today, if I talk about today is industrial revolution 4.0. which includes about Internet of Things. IoT is a very common term which people are using nowadays. And we also talk about cyber physical system and cyber physical systems and IoT. Robotics, additive manufacturing, these are some of the technologies. Industrial 4.0 revolution deals with, like if I am sitting here, a person sitting in a remote location, if he has or she has access to internet, they can, from their laptop or from their pad, they can operate and see how their factory is working. So this is what Industry 4.0, small fragment of Industry 4.0 talks about. So Industry 1.0 deals with steam power, mechanization. Industry 2.0 deals with electrical power and mass production. 3.0 deals with robotics, and 4.0, as you can see, a person is standing here, and with the help of different tools, it is just operating how a robot or two robots can interact with each other, multiple robots can interact with each other. Now let us see the key technologies which govern the Industrial Revolution 4.0. These are autonomous robot. As you can see, there are various autonomous robot nowadays, like in last 1 to 2 years, NASA sent a rover called Perseverance. It was an autonomous robot to study the surface of the Mars. So our India also developed a robot called DRDO. DRDO developed a robot called Daksh, which was a defense robot. So people like various countries nowadays are working in the direction of autonomous robot. We are also working in the direction of simulation. We don't have to manufacture product to see how is it working. There are various digital manufacturing tools or analysis software which through which we can see whether our product is facing or which kind of stresses or how the product will be look like when we make it. It talks about IoT, Internet of Things, it talks about cyber security, it talks about cloud computing, it talks about additive manufacturing, and it talks about augmented reality and big data. So for this presentation point of view, we will be focusing more on additive manufacturing, because that is what we'll be talking about. It deals with manufacturing. So additive manufacturing is nothing but 3D printing. We'll be discussing more about it in subsequent slides. So here in this you can see all of these machines are connected by an Ethernet, basically an internet system. So all of these machines, they are interlinked together, and a person standing here or here, they can see how all the machines and all the operations are being performed in a factory. So this is what Industrial Revolution 4.0 is all about. Now let us focus more on additive manufacturing. So additive manufacturing is defined as a process of joining materials to make objects from 3D model data, usually layer upon layer, as opposed to subtractive manufacturing methodologies. So here let us try to understand it with the help of a diagram. Here in figure A you can see there is a material. Now this process is a subtractive manufacturing process. In subtractive manufacturing, suppose we want to develop this kind of object, we took a material, we put it through a manufacturing process, and we manufacture this. So what we get is we get waste. Now if we talk about additive manufacturing, what you do is use a material, you put it through a 3D printing technology, or you can say put it here in the nozzle, and you make this product with the help of additive manufacturing process. Then there is very little amount of waste. So the advantage of additive manufacturing, it is very easy. And waste generated is also very less, and there are various types of material which you can use to manufacture a product. So now let us start a video to see how the additive manufacturing process essentially works.
3D printers have been used to make all kinds of amazing objects, like prosthetic limbs for children, actual biological tissue, working bicycles, and they've even been used by astronauts to print objects in space. So for all you Harry Potter fans out there, we're now going to show you how you can create a Harry Potter set of glasses for yourself on a 3D printer using plastic. The first step in the series is to take the digital file of this object and examine it for errors. Once you have a correct file, we can move to the next stage, which is to actually decide the print settings for this object, the speed of the print nozzle, the temperature that you will melt the plastic to before printing, and many other similar details. Once you've worked out this set of settings, you feed this into the computer and then hit print. During printing, the 3D printer will tell you how much of your print is complete by giving you a percentage and estimating how much time is left to complete the print. This technology is being used by people in a very wide range of sectors, including product design, architecture, aerospace engineering, jewelry design, automotive engineering, and defense. If you have an object that's quite high in its vertical dimension, this means that the printer will have to make a large number of horizontal layers, each one above the other, while making your print. This will increase the print time. Typically, print time varies from about 15 minutes to 10 hours. The most common materials for 3D printing are plastics such as PLA, ABS, and nylon. But you also get printing technology these days that can make objects from ceramic or metal powders and convert them into actual metal or ceramic objects. With this technology, manufacturers can customize every single product to your own specification. For example, if you're ordering a car, you could order the car in one of many different body shapes listed on the manufacturer's website, or perhaps even in a shape that you have designed. Let's look at this phone and see if we can create a new cover for it instantly right in this office. While printing, you have to be careful that the geometry of your object is clean and that your print is not shifting during the print. You have to keep it anchored and firmly stuck to the build plate. In addition, you have to ensure that any cantilevers or projections from the print are handled correctly by the printer. It's the speed and ease with which you can create these physical models of your ideas and products that actually transform the whole design process. Printers at the moment are available in the price range of say 50,000 to 2 or 3 lakhs for the most basic technology, which is called FDM or Fused Deposition Modeling Technology. The next other more expensive technologies are SLA and SLS printers, which can range from 3 to 6 or 7 lakhs each. While the market in India is just starting to take baby steps, we feel that in 2015-16 the market is really going to explode and affect all of us in ways that we never imagined.
So I hope this video was very informative to you. Now let me show you the glance of our Center of Excellence, that is AKGC PLM Center of Excellence. So we established this MOU with Siemens in the year 2012, 12th December 2012, and at that time it was North India's first center for competence in product lifecycle management. Now it's an initiative of Siemens India Group and AKGC to support the needs of manufacturing industries, young engineers, students, and concerned professionals. So I'll show you the glimpse of Center of Excellence over PLM. So this is our lab in which we do the design and analysis software, and this is the AKGC Fab Lab, in which there are various 3D printers and fabrications machines. So these are some of the facilities which are available at Fab Lab. This is the MakerBot 3D printer, and its build volume is 30 centimeter length, 30.5 meter width, and 45.7 meter height. This 3D printer is of MakerBot, and this 3D printer Stratasys F370. It is of industrial grade 3D printer given to us by Stratasys, and the material which can be used to print in this is ABS, PLA, and ASA. And these are some of the products, some of the inventories which we have in Fab Lab. This was the project given to us by Air Force, and this is the Humsafar coach, and this is the project which was developed by during the FDP, which was given to us by AICT, Idea Lab FDP. This is a memento which has used 3D. This is a 3D printing bulb, and this is a laser. This is the acrylic sheet manufactured by the help of laser cutting machines. Now, in regard to this, we also give training in the PLM lab, in which we teach about the students about the solid edge design software, which is used to which is used for product life cycle, which is 2D sketching, 3D modeling, assembly, motion simulation. So these are some of the modules which are used. Similarly, we also teach students about NX CAD/CAM software, milling operations. So this is software used for computer-aided design, computer-aided manufacturing, and computer-aided engineering. And we also give training on digital manufacturing, which consists of the CAD/CAM, NX CAD/CAM software, basics of additive manufacturing. We also teach about FabX Ultimaker, Stratasys F370. We also teach students how to work on 3D scanner, plasma cutting machine, laser cutting machine, milling machine, and hands-on working on vinyl plotter. And these are some of the training status at AKGC, and we have trained total so far 100+ students our PLM Center of Excellence, and there were 90+ students from AKGC and 15+ students of non-AKG students. We teach students about analysis and design modification. So to conclude this presentation, we discussed about design for manufacturing, how DFM principle works, what do we mean by design, how we can alter the design in later stages so that it can be fed into for manufacturing. And we also study why it is important to choose a manufacturing process wisely. And we also discuss about industrial revolution and how this key technology, that is additive manufacturing, it's important for us. So Industry 4.0 is focused on integrating all the technologies on one platform, and DFM design for manufacturing will play an important role in converting present manufacturing system into smart manufacturing system. And new technologies like 3D printing, CAD/CAM will play an important role in shaping new India. So that will be all from my side, and thank you everyone for listening to this presentation. Now, if anyone have any questions, please ask me.